Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, welcome back. We're going to look over the homework for lesson 9.1.4. These are the M&Ms for the exterior angle theorem for triangles. First of all, let's make sure we understand how to find an exterior angle of a triangle. You've got your three sides of the triangle, and then one of those sides gets extended. And so with that extension, more angles are created. This angle, oh, I didn't want to do that. Don't go there. Let's do this. Okay, so this angle, which is formed from the extension of this side of the triangle, and one of the sides of that angle is another side of the triangle, this is technically an exterior angle. So what the exterior angle theorem for triangles states is that this angle here is going to be equal to the sum of the two remote interior angles. Now let me explain why that works. There's some logic to it, and that's what I've got written right here. First of all, we know that angle 3 and angle 4 are supplementary to each other. They form a straight line, and supplementary angles are always equal to 180 degrees. So angle 4 plus angle 3 is going to be equal to 180 degrees. We also know from triangle sum theorem that angles 1, 2, and 3, when added up together, will always equal 180 degrees as well. So with that being the case, if this angle here plus angle 3 equals 180 degrees, and these angles here, when added to angle 3, equals 180 degrees, that must mean that they're equal to each other. So the sum of these two angles must be equal to this angle, just using basic algebraic logic. So what do we remember from this? The sum of the remote interior angles are always going to be equal to the exterior angle. And the remote interior angles are the ones that are not adjacent to the exterior angle. Angle 3 is right next to it. It's a next door neighbor. They're adjacent to each other. So the two that are not adjacent are the remote interior. So add those two together, they will equal this angle here. What do we have here? We've got scale factor. I guess, okay. So I think you guys are really rocking at this. You know that 3 times something equals 15. That something has to be 5. So you're going to multiply 8 times 5 to give you the y, and then you take 38, either divided by 5 or times the reciprocal of 5 will give you the value for x. So when showing this process, I think this is pretty straightforward. 8 times 5 gives you the 40, so that's what we have for y. But 38 times, let's go ahead and multiply times the reciprocal. So going in this direction, the scale factor will be the multiplier that's less than 1. That's the 1/5, and you end up with 38 over 5, which is 7.6 once you do those calculations. There might be, I'm not quite sure, I think the book and the online book, the physical book we have in class and the online book had different numbers here. If yours, if it said 38.5 instead of 38, then I believe this answer becomes 7.7. You would have done it correctly. I remember there being some issue with this in years past, so maybe you have that for an answer, and if this was 38.5, then that's correct. All right, sketch an example of each type of graph. Linear means straight line, and decreasing means from left to right as you read it. The value for y goes down as x increases. So this is a negative slope kind of a line with a negative association. It's decreasing. A nonlinear increasing means it's going up over time, assuming the x-axis is time, but it doesn't form a straight line. So exponential graphs, exponential growth has this slight kind of curving. That's nonlinear. All right, what do we have here? We've got the process for creating box plots. You have to put these numbers in order from least to greatest. Then you find, we didn't find the minimum or the maximum, but those are always easy to find for your box plots. But the median is always the number in the middle. So count up the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's an odd number, so it means that your median is going to be a single number in the middle. That's easy right there. Now the quartiles. those are the medians of the lower and upper half of your data. So we take every number that's less than your median, and there's 1, 2, 3, 4, 5 of them. So we've got our first quartile has to be 48. And then the same thing happens here. You got 97 in the middle of those 5 numbers. So the third quartile will be 97. So your minimum, your lower quartile, your median, your upper quartile, and your maximum can all be plotted on a number line, and then the box plot created just below that. The box plot is a good data display if you want to see the spread of the data, and if you want to find the mean or the average. The interquartile range, which is that box, let me just go ahead and draw you a random box plot. Looks perfect. Yes, there's your median, there's your minimum, there's your maximum. This is really good for finding like an average, seeing the spread of the data to see if there appears to be any outliers. And you could even consider this interquartile range as a broader average. 50% of the data falls in this middle. And the average, which is the median, is always what is in the middle of your numbers. So just something to think about. All right, solve the system of equations first by graphing, and then by using the equal values method. So when we graph these, we look to see, hopefully they're both in slope-intercept form. So we've got our y-intercepts and then our slope ratio. So starting with the first graph, let's take our y-intercept that's at 1. We plot that point. And then the slope ratio was, what was it, -1? So you go down 1, 1 to the right, down 1, 1 to the right, down 1, 1 to the right, and then connect all of those dots for this equation. Then do the exact same thing for the second equation. Here, our y-intercept is at 7, and then the slope ratio is up 2, 1 to the right, up 2, 1 to the right, but we're going to run out of room, so we can go down 2, 1 to the left, and keep going and graph those. Now, that's just the shortcut way. If you wanted to set up tables and plug in a series of values for x and find out the corresponding values for y, that's what every one of these ordered pairs will give you for the 2 equations. Well, where do they intersect each other? That is the solution to the system, their intersection point. This is where x is equal to -2 and y is equal to +3. So this here is our solution to the system. Now, if we want to solve using the equal values method, remember, if y is equal to this and y is equal to that, then this must be equal to that. So we're going to set that up as an equation, and it's set up for us to solve for x first. So we'll add 1x to each side, take away 7 from each side, then divide by 3, and you see that x at our intersection point of these graphs is at -2. So now all we have to do is take one of these equations, but we could do it in both of them if we wanted to, and it would work for both. If x is equal to -2 here, then that becomes -4 plus 7 is 3. And if x is equal to -2 here, then the opposite of -2 is +2 plus 1 is also 3. So you see how y is equal to 3, and you get the exact same solution. There are a number of different ways that you can solve a system, one by graphing, one by using the equal values method, but you'll learn some others when you're in high school. It just depends on the situation and the equations that you're given, which one is the easiest one to work with. What do we have here? Triangle sum theorem. These triangles all add up, all their angles add up to 180 degrees. So if I want to solve for this, I'm going to add these two together, which is 120. X plus 120 equals 180. Subtracting 120 from each side means that x has to be equal to 60 degrees. This one's a little bit more complicated because you've got to combine like terms. So we know that 2x plus x plus 12 plus 96 equals 180 degrees. So I'm going to call that 3x's. And 96, what is that, 108 is equal to 180. So I'll subtract 108 from each side. And we end up with 72. So 3x's is equal to 72. Divide each side by 3, and you will see that x equals 24. Now, if you want to prove this is correct, here it's pretty easy, but here, double 24, and that's 48 degrees. Then here it's going to be 24 plus 12 is 36 degrees. Add those three together, they're going to add up to 180 degrees. So that proves that our answer is correct. One other element here, just keeping in mind the difference between an acute triangle, a right triangle, and an obtuse triangle. All acute triangles have angles that are less than 90 degrees. All right triangles have one 90-degree angle, which here's the 90-degree angle here. And then when you're working with obtuse angles, all obtuse angles have, where are you obtuse angles? Is this obtuse? Yes. Have one angle that's greater than 90 degrees, but the other two are going to be less than 90 degrees. Okay, so this qualifies as an obtuse because of a 96-degree angle. And since every one of these angles was less than 90 degrees, this one qualifies as acute. All right, checkpoint problem. Jason's interested in buying a used Panda hybrid because he heard that it's incredible gas mileage. What did he hear about it? It just has incredible. Yeah, he likes the gas mileage. So he collected this data here. Now, if Jason would like to know the typical cost of advertised pandas, what kind of a graphical display would that be? Well, when we were talking about the box plot, that's really good at finding like the middle or the median, and that's another term for average. So the typical cost is like the average cost of these. You could use the box plot, but I don't know why you would want to do that. Just add them together and find the mean, or put them in order from least to greatest and find the median. You don't really need to finish the box plot to answer that question. What type of graph could be used to display the relationship between the age and the cost? That's where the scatter plot comes in. You're trying to look and see if there is a correlation or an association between the age of a car and their cost. So let's make a scatter plot for this data, and as you can see, this is a very strong negative correlation. As the car gets older, this Panda hybrid, the cost goes down. So our line of best fit that we're going to use for this is going to be very accurate because it's such a strong association. Does it ask us to find a line of? Yes, it does. So we would have to find some lattice points here, and we would have to predict what does that y-intercept appear to be. What am I counting by? 6, 12. So these are counting by threes, so that's 33. That's probably about 35 right there. So that looks like the new price of these cars is about $35,000. And let's see, if we go from here to another known point, are there any obvious points here? This one's pretty close. Oh, look at that one right there. I like that point. What is this? We're counting by 1, so that is 12, 0. So that's it. No, I can't deal with that. Must write this properly. So 12, 0. And this one was 0.35. So how much does x change? Remember, the change in y over the change in x is how we're going to find the slope ratio. The change in x is 12, and the change in y is 35. And, you know, maybe that's going to be closer to 36. You know why I might want to change that to 36? Because that gives us a slope of -3 instead of some horrible decimal number. So I'm going to make that our slope, and the y-intercept is about 35 or 36, somewhere in there. So you can use this to predict what the cost of a 6-year-old car would be, because you would just take 6 times 3 is 18, and then subtract the 18 from the 35, and I got 17,000. But if you had written that as 36 instead of 35 here, then it would be 18,000, which is, you know, pretty close. And that's it. We're done. All right. So over the next few days, we're going to be preparing for the first Chapter 9 test, which is only going to be on these angle pair relationships and these different angles and attributes of triangles. So I'm going to put out study guides tomorrow and on Wednesday. And I'm not quite sure. The test will probably be done on Friday as we normally do it. Then you'll have the weekend to make sure that you review everything and you're on top of it. And just as long as you take the test by Sunday, everything will be good. Some of you still have to take that Chapter 8 test number 2, and there's zeros in the grade book. So I have a sneaky suspicion the people who aren't taking that test probably aren't viewing this video. I don't want to get too Debbie Downer on everything, but the people who don't do their homework probably aren't checking this email either. So that needs to get done. And I've sent out emails, and that 0 is going to get locked in the grade book if it doesn't get taken care of this week. So hopefully you're on top of that and you get it taken care of. All right. Good luck on your study guides over the next couple days, and good luck on the test on Friday. Take care.
Hey, feeling good, like I should. When in dark,